take a look at these two charts. Chart A is a line chart showing the changing closing stock price for several companies. Chart B shows the proportional change of closing prices for several companies. In both charts, the changes in price over time are easy to spot based on the angle of the line or area. Which chart communicates the insight the best? Well, the short answer is it depends. The line chart reveals the changes in real dollars over a specific time period. Area charts show proportional change over time. If these were stocks in your portfolio, showing this proportional change over time makes a lot of sense. However, if you had a more diversified portfolio, it may not. Data format for time series. Whether you're creating area or line charts, the format of your data matters. This is one way you may see time series data structured. Each date is listed as a column or variable, and each company is listed as a row or observation. How would you visualize this data? What variable would you map to the x-axis and the y-axis? Since each date is coded as a variable, you'd have to select a range of variables to plot on the x-axis. Most software won't give you the result you're looking for. A simple line chart showing each stock as a line over the time values on the x-axis. This format makes visualizing this time series difficult. Here's another way you may see time series data structured. A column for each date and for each company. The rows give the closing stock price for each company. How would you visualize this data structure? Well, it's easy to plot year on the x-axis, but this requires plotting 4 variables on the y-axis. Usually, you only plot 1. This format works for some simple line graphs, but it could become cumbersome when you want to change to another type of time series chart, such as a stream graph. As you develop your eye and skills in visualization, you may want to start adding some conditional statements based on a variable, such as, if stock value is less than or equal to some number, then highlight that value. This type of logic would work no matter how many stocks were added to the portfolio. However, when each company is treated as a variable instead of a value, that is, each stock is arranged as a column rather than a row, recoding these conditional statements will be necessary every time a new company is added to the dataset. A better option is to plot 1 variable on each axis. To do this, the data should be in a long format. Each observation is structured as a row, and the variables, date, company, and price, are structured as columns. The objective is to map date to the x-axis and price to the y-axis by company. A long format for this data makes it easy to map date on the x-axis and price on the y-axis. The companies can be shown through different color lines. Five-day moving average. The moving average is a widely used indicator in technical analysis that helps smooth out price action by filtering out noise from random fluctuations. A moving average is a trend-following or lagging indicator because it is based on past prices. The two basic and most commonly used moving averages are the simple moving average, which is a simple average of a security over a defined number of time periods, and the exponential moving average, which gives bigger weight to more recent prices. Let's look at the simple 5-day moving average for Apple. Here you can see the green line smooths out the closing price fluctuation over time. To calculate the 5-day moving average is easy. Add up the previous 5 days of the closing stock price and divide by 5. For example, for moving average value of September 19th, take the price for September 13th, 14th, 15th, 18th, and 19th and divide by 5. The moving average is 159.04. And the closing price for the day is 158.73. To visualize the 5-day moving average, first plot the closing price by day per security as a basic line chart. Then add a second axis to plot an additional line. Year over year. Sales, profits, and other financial metrics change during different periods of the year because most lines of business have peak and low demand seasons. The year-over-year metric is useful for showing the percentage change from one year to the next. Let's say we wanted to compute the year-over-year revenues by quarter for Amazon. We would need the revenue by quarter for 2 years. We can visualize it and show the percentage change from one year to the next by quarter from 2016 to 2017. It's one thing to look at Amazon's annual revenue, but break it down by quarter. Each quarter is steadily increasing in the next year. The math behind it is simple. For example, take Q1, subtract Q1 2017 from Q1 2016, which is $6.58 billion, or a 22.59% increase. In summary, when working with time series data, study the structure of your data. Use a long format where each observation is a row and the variables such as date, company, and price are organized into columns. In addition to just showing the values per unit of time, consider calculating other metrics, such as the moving average. Here you can look at the smooth data rather than focusing on the day-to-day price fluctuations that are inherent in all financial markets. Or use the year-over-year calculation to show percentage change difference from one year to the next, and to show change by seasonality, such as month or quarter.